Parte dança Kerby, Star Dance, Juventude Esportiva Ligense, ODS Associação, Star Dance, ODS Associação, Prestes Dance, Prestes Dance, Ritmo das Formas, Ritmos União Setubalense, Ritmo das Formas, Sociedade Filarmónica Moitense, Ritmos União Setubalense, Sociedade Musical 5 de Outubro, Sociedade Filarmónica Moitense, Sporting Clube de Espinho, Sociedade Musical 5 de Outubro, Sporting Clube de Espinho, Time for Satisfaction, Studio Dance DN, UDC Aldeia do Sobrelinho e por último Time for Satisfaction, UDC Aldeia do Sobrelinho e por último Shira Dance Academy. Um pouco mais para trás, eu vou chamar os júris que se vão ficar à frente, um bocadinho para trás só. Tem que chegar um pouco mais para trás, eu vou chamar os júris que se vão ficar à frente, um bocadinho para trás só. Vou chamar a atenção agora, vou chamar o júri, judges, Uta Albanese, Germany, Silvia Carvalho. Vou chamar a atenção agora, vou chamar o júri, judges, Uta Albanese, Mónica Gomes, Silvia Carvalho, Helena Gozum, Radianich, Mónica Gomes, Tomás, Helena Gozum, Eduardo Coroti, Radianich, Milene Matias, Tomás, Karina Rubio, Eduardo Coroti, Henrique Sordó, Milene Matias, Stevlana Teverionovic, Henrique Sordó, Boris Zaltzman, Telma Torres, Marina Rodrigues, Stevlana Teverionovic, Paulo Paulino, Boris Zaltzman. Chama agora também o Sr. Presidente da Associação da Dança de Setúbal, Sr. Paulo Martins, Paulo Paulino, o Sr. Presidente da Federação Portuguesa de Dança Desportiva, agora também Alberto Rodrigues, o Sr. Presidente da Associação da Dança de Setúbal, Sr. Paulo Martins, o Sr. Presidente da Federação Portuguesa de Dança Desportiva, Sr. Alberto Rodrigues.
Palmas e esse calor humano. Peço desculpa ter que ler o discurso, mas isto é muita coisa para muitas pessoas para agradecer e muitas entidades. Ora, muito boa noite a todos. Ser o apoio que nos têm dado para a realização deste Campeonato Nacional. Essas palmas e esse calor humano. Dirijo-me a todos vós, peço desculpa ter que ler o discurso, com bastante orgulho e alegria para muitas pessoas. Dois dias de competição não são fáceis de organizar, também para enaltecer o apoio que nos tem dado. É o primeiro dia, para a realização teremos deste Campeonato Nacional, portanto passo a ler. Dirijo-me a todos vós, com bastante orgulho e alegria. 2 dias de competição não são fáceis de organizar. Hoje é o primeiro dia, amanhã teremos mais. Não há papel, vai mesmo sem papel. Bem, então não poderia deixar de agradecer à Associação Cultural e Costa da Caparica, que se juntou à Associação de Setúbal Dança Desportiva na organização deste evento. Não há papel, vai mesmo sem papel. Bem, então não poderia deixar de agradecer à Associação Cultural e Costa da Caparica, que se juntou à Associação de Setúbal Dança Desportiva, foram imprescindíveis para que este dia tivesse qualidade na organização deste evento. Também uma palavra de agradecimento à Câmara Municipal de Almada e à Junta de Freguesia Costa da Caparica, por nos apoiarem, por nos cederem o espaço todos para a realização desta maravilhosa competição. Também uma palavra de agradecimento à Câmara Municipal de Almada, agradecemos não só a Junta de Freguesia Costa da Caparica para realizar mais uma vez o Campeonato Nacional, por nos cederem o espaço, mas também a confiança para a realização desta maravilhosa competição. Muito obrigado. A todos os nossos, à Federação Portuguesa de Dança Desportiva, a todos os nossos patrocinadores, o Boticário, para realizar mais uma vez o Campeonato Nacional, único, mas também a confiança, Alfredo Dias da Silva e Filhos, B-Dance, muito obrigado. Talho das Bifanas, a todos os nossos, e Manuel Gomes, a todos os nossos patrocinadores, a todos vocês, muito obrigado. Boticário, Delta, Dora, Único Moment, Alfredo Dias da Silva e Filhos, B-Dance, Talho das Bifanas e Manuel Gomes Martins. A todos vocês, muito obrigado pelo vosso apoio e pela vossa ajuda. Quero ainda deixar um agradecimento especial às escolas, clubes, associações, familiares e amigos dos nossos atletas e ao público em geral por estarem sempre presentes e por nos acompanharem neste magnífico mundo da dança. E como não poderia deixar de ser, deixo o meu último, mas não menos importante agradecimento a todos os atletas pela presença, pela energia, pelo espírito de equipa, pela perseverança, pela força e pela alegria que depositaram na vossa dança diariamente, mas hoje em particular, deixo-vos o meu louvor. Sem vocês, este dia não teria qualquer significado. Portanto, foi para vocês que nós trabalhamos e foi para vocês que organizámos esta competição. Despeço-me na esperança que tenham desfrutado do espetáculo e que continuem a desfrutar e que tenham reparado em todos os pormenores e toda a dedicação que nós, a organização, depositámos nesta competição para que para todos vocês fosse um momento único. Portanto, um resto de uma boa competição, muito sucesso, quer pessoal, quer desportivo.
Muito boa noite. Eu gostaria, em nome da Federação Portuguesa de Dança Desportiva, em primeiro lugar, agradecer e dar os parabéns à Associação de Setúbal e à Associação Cultural da Costa da Caparica por se terem proposto organizar o Campeonato Nacional. Nestes moldes, inovámos este ano em 2 dias. Penso que é melhor para toda a gente, principalmente para os atletas que fazem as 10 danças, que têm mais tempo e tranquilidade também para competirem de igual forma com todos os outros competidores. Obrigado. Esta prova, pela sua envolvência e grandeza, só com grande espírito de sacrifício e de aventura e de grande dinâmica é que é possível organizar. A Associação de Setúbal, nos últimos 3 anos, organizou 2 campeonatos nacionais e para nós é com grande satisfação vermos uma associação dinâmica, interessada em ajudar a desenvolver a dança, habitua-nos a elevar a fasquia, dar um pouco mais de requinte a esta arte que tanto gostamos. Gostaria também de agradecer à autarquia da Almada e à Junta de Freguesia da Costa da Caparica, que são importantes para ajudar a desenvolver qualquer modalidade, nomeadamente a nossa, que é pequena. A todos os patrocinadores que também ajudam quem organiza a facilitar muita coisa. Gostaria de agradecer ao painel de júris. Cada vez é mais difícil conseguirmos ter painel de júri internacional para jurar um campeonato nacional. Temos aqui 9 juízes de prova internacionais de renome e 6 juízes de prova portugueses do melhor que há. Gostaria, por fim, de agradecer a toda a estrutura federativa que nos ajuda a manter a dança viva, nomeadamente as associações distritais, os clubes, os treinadores, que dia a dia ajudam-nos a pôr a modalidade sempre um passo mais à frente. Para finalizar, gostaria de agradecer aos pais, que sem eles era praticamente impossível. E por fim, ao mais importante, são os atletas. Muito obrigado, continuem a sonhar e glória aos vencedores e honra aos vencidos, que ganham melhor. Muito boa noite e obrigado.
O chão vai ser limpo agora. Atenção, Adultos Open, primeiro hit, 547, 52, 53, 55, 69, 72, 74 e 576. Samba.
Eu gosto. Você gosta? Eu gosto. Você gosta? Eu gosto. Você gosta? Você gosta de funk? Eu gosto.
Segundo hit, 537, 45, 59, 60, 65, 66, 73 e 575. Samba.
Eu gosto. Você gosta? Eu gosto. Você gosta? Eu gosto. Você gosta? Você gosta de funk? Eu gosto.
Terceiro hit, música.
gosta? Eu gosto. Você gosta? Eu gosto. Você gosta? Você gosta de funk? Eu gosto.
Primeiro hit. Música.
Sono un ragazzo sincero, da dove cresce la palma. Sono un ragazzo sincero, da dove cresce la palma. E prima di morire io chiedo un verso puro dall'alma. Guantanamera, Guaira Guantanamera, Guantanamera, Guaira Guantanamera. In giugno come in gennaio coltivo una rosa bianca. In giugno come in gennaio coltivo una rosa bianca, perché l'amico sincero mi dà la sua mano franca. Guantanamera, Bahia Guantanamera, Guantanamera, Bahia Guantanamera. Un verso ed un
Segundo hit.
chiaro, uno di un cremisia.
Tchá, tchá, tchá.
Sono un ragazzo sincero, da dove cresce la palma. Sono un ragazzo sincero, da dove cresce la palma. E prima di morire io chiedo un verso puro dall'alma. Guantanamera, Bahia Guantanamera, Guantanamera, Bahia Guantanamera. In giugno come in gennaio coltivo una rosa bianca. In giugno come in gennaio coltivo una rosa bianca, perché l'amico sincero mi dà la sua mano franca. Guantanamera, Bahia Guantanamera, Guantanamera, Bahia Guantanamera. chiaro, uno di un cremisi acceso, un verso e di un verde.
Terceiro, It. Música.
Sono un ragazzo sincero, da dove cresce la palma. Sono un ragazzo sincero, da dove cresce la palma. E prima di morire io chiedo un verso puro dall'alma. Guantanamera, la ira Guantanamera, Guantanamera, la ira Guantanamera. In giugno come in gennaio coltivo una rosa bianca. In giugno come in gennaio coltivo una rosa bianca, perché l'amico sincero mi dà la sua mano franca. Guantanamera, la ira Guantanamera, Guantanamera, la ira Guantanamera.
Primeiro hit. Rumba.
E por falar em saudade, onde anda você? Onde andam seus olhos que a gente não vê? Onde anda esse corpo que me deixou morto de tanto prazer? E por falar em beleza, onde anda a canção que se ouvia na noite? Dos bares de então, onde a gente ficava, onde a gente se amava em total solidão. Hoje eu saio na noite vazia, numa boemia sem razão de ser, na rotina dos bares, que apesar dos pesares me trazem você. E por falar em paixão, em razão de viver, você bem que podia.
Segundo hit.
Alô, viado. Tá vivo?
Música.
E por falar em saudade, onde anda você? Onde andam seus olhos que a gente não vê? Onde anda esse corpo que me deixou morto de tanto prazer? prazer. E por falar em beleza, onde anda a canção que se ouvia da noite, dos bares de então, onde a gente ficava, onde a gente se amava em total solidão. Hoje eu saio na noite vazia, numa boemia sem razão de ser, na rotina dos bares, que apesar dos pesares me trazem você. E por falar em paixão, em razão de viver, você bem que podia me aparecer.
Terceiro hit. Rumba.
E por falar em saudade, onde anda você, onde andam seus olhos que a gente não vê, onde anda esse corpo que me deixou morto de tanto prazer. E por falar em beleza, onde anda a canção que se ouvia da noite, dos bares de então, onde a gente ficava, onde a gente se amava em total solidão. Hoje eu saio na noite vazia, numa boemia sem razão de ser, na rotina dos bares, que apesar dos pesares me trazem você. E por falar em paixão, em razão de viver, você bem que podia me aparecer.
Primeiro hit. Atenção, passo doble. Segundo hit. Atenção. Passo doble. Terceiro hit. Atenção. Passo doble. Os pares que vão fazer finais vão ter que sair lá ao fundo, por favor. Do meu lado direito, só olhar para mim, lá ao fundo, do meu lado direito. Primeiro hit. Jive.
Rumors spreading round United Texas town about the shack outside the game. And you know what I'm talking about. Just let me know if you wanna go to that home out on the range. They got a lot of nice girls. I'm waiting.
Down.
Segundo hit. Jair.
Rumors spreading round United Texas town about the shack outside the game. And you know what I'm talking about. Just let me know if you wanna go to that home out on the range. They got a lot of nice girls. I'm waiting. Well, here it's fine if you got the time and the chance to get yourself in. And here it's time almost every night. But now I might be mistaken.
Último hit. Shave.
Rumors spreading round United Texas town about the shack outside the game. And you know what I'm talking about. Just let me know if you wanna go to that home out on the range. They got a lot of nice girls. I'm waiting. Well, here it's fine if you got the time and the chance to get yourself in. And here it's time almost every night. But now I might be mistaken.
Obrigado. De seguida vamos ter a final de Juniors Open Standard. Apresentação para. Primeiro para Rafael Almeida, Bárbara Silva, Academia de Dança. Tomás Gomes e Gabriela Teixeira, também da Academia de Dança. José Pereira, Elizabeth Martinov, Prestes Dance. E por último, Diogo Martins e Inês Marques, Ritmos União Sobelense. Obrigado. Está feita a apresentação dos pares Júniores do Open que vão competir na sua final em standard. Convido agora os pares a entrarem, por favor. Música. Música. Valsevianense.
Come along, it was a bright day. Shouting out, you have some things to say. It's not the time for telling tales on me. So come along, it won't be long till we return. Happy, shut your eyes, there are no lies in this world. We fall asleep, let's deserve this day of hurt tomorrow. We'll be free. Last night fight, I'm tired, can we just sleep? Tonight, turn away, this is nothing left here to say. Turn around, I know I left the tomb to fall. It's been rough, but we'll be just fine. We'll work it out, yeah, we'll survive. We mustn't let a few bad times dictate. So come along, it won't be long till we return. Happy, shut your eyes, there are no lies in this world. We
Música.
Se le ragazze di New York mi piacciono di più, e perché quel sogno passa sempre al mare. In ogni senso vuole andare. Vorrei sentir gezzare un trio, vivere dentro un film anch'io, come il leone della metro, come in me, che dava inizio ai sogni miei. Oh certo, meglio là che in culo al mondo, meglio niente di secondo.
Questo è.
If you ever plan to motor west, just take my way. That's the highway, that's the best. Get your kicks on Route 66. It winds from Chicago to LA.
Senior TS Open Standard, João Santos e Manuela Santos. Pedro Ferraz e Gisela Couto. António Cardoso e Maria Júlia Santos. Carlos Caínso e Julieta Caínso. José Pérez e Eunice Godinho.
Arduinos. I'm going to talk about what they are, what they can do, and the basics of how to set one up to do simple things like make an LED dimming circuit, control the speed of motors, and even make a simple oscilloscope. So what is an Arduino? I'm sure you've heard about these things a million times by now, and if you're confused, you have every right to be, because the word Arduino refers to so many different things. Keep watching and I'll explain all of them. Microcontrollers are integrated circuits that are basically tiny computers. They can run small, simple software programs. They're low-powered enough that they can be powered by a battery for days, but they're fast enough to process data much faster than any human being can think. Arduino is a company in Italy that designs and sells circuit boards that make microcontrollers easy to use. They call these circuit boards Arduinos, and there are a lot of different types of Arduinos. For example, you've got simple Arduino boards like the Arduino Uno, which is cheap and good enough for most projects. You could use an Arduino Uno to control motors, lighting, cameras, or even build a simple robot. And then you have more fancy Arduinos with more powerful processors, which have Wi-Fi, Ethernet, and more. The company Arduino open sources all of their hardware designs, which means that you don't just have to buy from them. There are countless third-party companies that make their own variants of the Arduino hardware designs. They can't call them Arduinos, but functionally they're the same thing. There are also these things called Arduino shields, which are basically circuit boards that plug into your main Arduino circuit board and let you do more stuff. For example, Adafruit makes shields that let you control motors and servos without having to design motor control circuitry. And SparkFun have shields that let you turn your Arduino into a simple cell phone or an MP3 player. Okay, so that was a quick overview of Arduino the company and Arduino hardware, but there's more. There's also the Arduino software development environment, and this is what makes Arduino good for beginners. Historically, if you wanted to program microcontrollers, you'd have to type out a lot of binary and memorize a lot of hard-to-remember registers and instructions. Then you'd have to use special programming hardware with custom-made cables to upload your program onto your microcontroller. Arduino, the company, got rid of all of that. They created software that works on Windows, Mac, and Linux, which makes uploading your code as simple as connecting a USB cable and clicking a button. They created a programming language that lets you configure all of the Arduino hardware products in the same way. And although it's not as simple as learning Python, the Arduino software is one of the easiest programming experiences you'll ever have. Okay, so hopefully that clarifies what Arduino means in different contexts. Now, when people say they used an Arduino for their project, they're probably talking about the Arduino Uno. It's highly unlikely that you'll outgrow one anytime soon, so it's the perfect Arduino hardware for this beginner's tutorial. You can get them from Amazon cheaply, and if you have the money, I recommend buying one of the many Uno kits out there where you get a lot of different pieces of hardware to play with. Okay, so you've got your Arduino Uno. The first thing I want to do is get you familiar with the hardware. You'll often hear Arduinos being called microcontrollers, and that's technically incorrect. Arduinos are circuit boards that have microcontroller chips on them, but they also have a lot of other stuff on there too. Let's take a quick tour. This is the microcontroller. Arduino Unos use a series of microcontrollers called Atmega AVRs. They're made by a company called Atmel. You can buy just the bare chips on their own for about $1, but then you'd have to do a lot of soldering. Connected to the microcontroller is a crystal resonator. This controls how fast the microcontroller is running. I have a separate tutorial on resonators and oscillators which you might find useful. Now, in order to upload the software you create to the main microcontroller, there's actually another microcontroller. This chip is what lets you connect your USB cable to the Arduino board and communicate via USB. It lets you upload your programs onto the main microcontroller, and once you have your program running, this chip is what allows you to send messages back and forth between your computer and your Arduino, and this is extremely important for debugging. One great thing about Arduinos is that you can power them purely from your USB cable. But if you don't want your project always attached to a computer, you can just use an external 9-volt DC power source with a barrel jack over here. The Uno has a built-in voltage regulator that'll reduce the voltage to 5 volts. And if you ever want to reboot your Arduino's program, you've got a reset button. If you have time, it's worth studying the Arduino Uno schematic. Don't worry if it looks complicated. You don't need to understand most of it. I'm just trying to get you to understand what the Arduino designers did. They took an off-the-shelf microcontroller that requires a lot of extra parts to get working, and they put all of those things together in an easy-to-use way. And if you choose to learn more about electronics, you can create circuit boards like this too. Okay, so that's what's under the hood. Next, let's talk about the pin connectors. Over here you have the power pins. If you want, you can connect wires here to other circuitry with 5 volts or 3.3 volts. Just make sure that whatever you power doesn't draw more than a few milliamps. A few LEDs is okay, but a large motor would be an Arduino.
Boo! You suck!
TX and RX is for sending and receiving serial data. You could use this port to send and receive data from a GPS module, Bluetooth modules, Wi-Fi modules, and more. Pins 2 to 13 are for digital inputs and outputs. Normally when people think of binary, you think of just spitting out zeros and ones. But with most microcontroller pins, you can actually activate a third state and use them as a digital input. So you can use this pin as an output where it spits out 5 volts for a digital 1, or 0 volts for a digital 0, or you can internally configure the Arduino to expect a voltage on the pin, and that voltage could be interpreted as a 1 or a 0. It's a system called tri-state logic, and it's worth reading up on, but Arduino makes it really easy to change between inputs and outputs in software. Here we have 6 analog input pins, and these are used to measure continuous voltages anywhere from 0 volts to 5 volts. I'll talk more about this later in the video. Finally, some of the pins have a tilde in front of them, and this means that you can use them to output pulse width modulated square waves, which I'll also show later in the video. Okay, enough about the hardware. Most of the work you do with your Arduino will actually be in the software. So start out by downloading the Arduino software from arduino.cc. During the installation, you can expect a lot of prompts like this to show up, where you're asked if you want to install various drivers. Just say yes to everything. Once you're done, connect the Arduino to your computer with a USB cable. Next, start up the Arduino development environment. The first thing that you want to do is make sure that the software tries to connect to the right type of Arduino. Go to Tools, Boards, and we're going to be using an Arduino Uno. Next, we have to make sure that the Arduino environment can actually connect and communicate with your Arduino. Go to Tools, Ports, and select the COM or serial port where your Arduino is connected. If there isn't an Arduino listed here, you may have a problem with your drivers, or you can try plugging your Arduino into a different USB port. The Arduino software has a ton of fantastic, easy-to-follow demo programs, and studying these is the best place to start learning how to code. Arduino calls them sketches, which is just a fancy name for a program that you upload to your Arduino. Let's start with an example where we measure voltages that are being fed into the Arduino. Go to File, Examples, Basics, Analog Read Serial. All the Arduino examples contain instructions on how to set up the hardware. This one is telling us, attach the center pin of a potentiometer to pin A0 and the outside pins to +5 volts and ground. Okay, let's do that. A 1K or a 10K potentiometer will work great for this. We're going to be using it as a voltage divider to create a voltage anywhere from 0 to 5 volts. Make sure you've watched my voltage divider tutorial if you don't understand how that works. Every Arduino program will have 2 main areas, the setup and the loop. The setup area is where you configure your Arduino to do certain things for the duration of your program. It could be information on which pins are inputs and which are outputs, but in this case we're telling it to send serial data to our computer at 9,600 bits per second, which is a pretty standard data rate for these situations. The loop is the area of code that repeats over and over again for as long as the Arduino has power to it. This line will measure the voltage on pin A0 and store the value of it in a temporary place in memory that we're calling sensor value. Sensor value is an int, or integer, meaning it's a whole number. Once we've copied the analog voltage reading to sensor value, the command serial.println will transmit that value from our Arduino through the USB cable to our computer, and we can view it. Click Upload. It'll compile the sketch and upload it to your Arduino. Now hit the Reset button. Now go to Tools, Serial Monitor. You should see a bunch of numbers flying by. As you vary the potentiometer from 0 to 5 volts, you should see a number on screen from 0 to 1023. This is because internally, the Arduino represents the analog voltages it measures with a 10-bit number, which can be from 0 to 1023. The number scales linearly with the voltage, so 2.5 volts would be halfway down at 512. You can use these formulas to convert from analog tick values to real-world voltages and vice versa. Now close the serial monitor and go to Tools, Serial Plotter. Now you can get a graph of the voltage your potentiometer is creating over time. It's basically a very simple low-bandwidth oscilloscope. Let's try another experiment where we build a simple LED dimmer. Go to File, Examples, Analog, Analog in Out Serial. The instructions for the potentiometer are the same as before. It also says to connect an LED from digital pin 9 to ground. Note that it is implied that you will put a resistor in series with the LED. The pins on an Arduino can't supply much current, any more than about 20 milliamps, and you risk permanently destroying that pin. I have detailed tutorials on LEDs and resistor values, but for now let's just use a 1K resistor attached to ground. The other side goes to the cathode of an LED, and the LED's anode goes to pin 9. We've already talked about what an int is, but this const int means that the label analog out pin will always translate to the number 9 throughout the rest of the program. For example here, saying analog write 9, output value wouldn't be very clear. Like, what the hell is the 9 for? Instead, we're declaring analog out pin to be a place in the Arduino's memory that always stores the fixed constant number 9. So when we write other pieces of code, we don't have to memorize which pin numbers we're using for different things. It's not a big deal right now, but this becomes more important when we have programs that use a lot of different pins. Sensor value and output value are non-constant integer numbers, which means they can change value during the operation of the program. The term for this in programming is a variable. On the Arduino platform, an int variable can hold a number anywhere between minus 32,768 and plus 32,767. The setup is the same as before, and once again we're using the analog read function to measure the voltage on a certain pin, which turns out to be pin A0. We store that value in sensor value. Now, we know that the Arduino internally represents analog voltages with numbers from 0 to 1023, but the analog write function only accepts values from 0 to 255. So we use the map function here to linearly scale sensor value down to values between 0 and 255. Then the analog write function takes the number stored in output value and uses it to control the voltage on analog output pin, which is in fact pin number 9. The serial printing stuff is similar to what we had before, and at the end of each loop the delay function will make the Arduino pause execution of all code for a specific number of milliseconds. Once again, we click Upload, hit Reset on the Arduino, and now we have a system that can control the brightness of an LED with a potentiometer. Now, you're probably thinking, so what? You can do that without the Arduino. Well, let's probe the output of pin 9 with an oscilloscope to see what's really happening here. We've got a pulse width modulated square wave. We can control it with the potentiometer, and it's very precise. Now instead of an LED, let's control something else. Let's take this part of the circuit from my classic pulse width modulation tutorial, and now we'll be able to control a motor digitally, instead of a sometimes glitchy 555 circuit. So you might be thinking that it's weird that an Arduino function called analog write is in fact controlling a pulse width modulated square wave. Well, the idea is that you would use an RC low-pass filter to convert that square wave into a continuous analog voltage, and I have separate tutorials on how to do this. Once you've looked at a few examples and understand how they work, you can delete pieces of code and modify existing pieces of code to create whatever you want. Here I've gotten rid of the potentiometer control and serial stuff, and I created a loop that turns a motor off for 1 second, turns the motor on at 50% speed for 1 second, and then goes full speed for 1 second.
just picture everybody naked. She really doesn't like to
So you can see how by reading voltages from sensors and writing code to control motors and servos, an Arduino can easily become the brains of a simple robot. In fact, you can get kits to build Arduino-based robots for as little as $74. So those were just 2 easy examples of what you can do with an Arduino, but you can do so much more, and there are tutorials all over the internet for them. Thank you for watching, and if you found this video useful, please check out my sponsor Audible. Audible is a company owned by Amazon, and basically they have a huge selection of audiobooks that you can buy and listen to on the way to work or when you're at the gym. They've got a promotion right now where you can get a free audiobook if you sign up for their free 30-day trial by visiting audible.com/afrotechmods. Once you're there, you can log in with your existing Amazon account. You need to give them a credit card number, but you can cancel your free trial at any time and you still get to keep the free audiobook. I personally like Ryan Holiday. He's got this amazing book called Trust Me, I'm Lying, Confessions of a Media Manipulator. He's got these crazy stories about how anyone can pose as a fake expert and get quoted in news articles. Once you pick out your free audiobook, you download the Audible app on your phone or tablet, and you can access your audiobooks from anywhere.
I have flown bloggers across the country, boosted their revenue by buying traffic, written their stories for them, fabricated elaborate ruses to capture their attention, and courted them with expensive meals and scoops.
If that sounds interesting to you, click on the link in the video description section or visit audible.com/afrotechmods to start your free trial.
Hi, this is Ben Finio with Science Buddies, and this video is an introduction to how to use a breadboard. This is a breadboard. It's a rectangular piece of plastic with a grid of holes that allows you to easily and quickly build electronic circuits by pushing electronic components into the holes. For example, simple circuits like this one with a battery and an on-off switch to control a light. You can also build more complicated circuits, for example, lights that flash automatically, or robots of all different shapes and sizes. There are far more examples than we can list in the beginning of this short video. At this point, you might be thinking that this doesn't really look like it has anything to do with bread. The name breadboard comes from the early days of electronic circuits when people would literally use wooden boards with screws or nails driven into them to make electronic connections. Modern breadboards are made from plastic and come in all shapes, sizes, and even different colors. The most common sizes you'll probably see are full-size breadboards, half-size breadboards, and mini breadboards. Larger and smaller sizes are available, and many breadboards come with tabs and notches on the side that allow you to snap 2 or more of them together, but a single breadboard will be more than sufficient for most beginner projects. Let's take a closer look at how a breadboard actually works. The holes of a breadboard allow you to easily push the leads or metal legs of a component like this LED into them and then will lightly hold them in place. This connection is strong enough that the LED won't fall out on its own, but light enough that if you make a mistake, you can easily pull it out and put it in a new location. Technically, these are called solderless breadboards because they can make these connections without using solder or melted metal to permanently bond electronic components together. Let's find out how breadboards can hold on to components without using solder. If you flip a breadboard over, they come with an adhesive backing that allows you to permanently stick them onto a project, for example, the breadboard stuck to this robot. If you remove that backing completely, like I've done with this breadboard here, you expose a series of metal strips that are inside the breadboard. These metal strips are what make mechanical and electrical connections to the components you insert into the breadboard. We can remove one of these metal strips by pushing it out from the front to see what it looks like up close. Each strip is a series of 5 clips that line up with the holes on the breadboard. When you push a component into the breadboard, these clips are what's actually grabbing onto the leads, like you can see here with this LED. This breadboard is actually made from transparent plastic, so you can see the clips from the outside. When you press a lead into one of the holes, it's just getting grabbed onto by one of these clips. Let's take a closer look at the writing on the front of your breadboard. Your breadboard has columns labeled from A through J, and rows that start with 1 and go up to a number that depends on the size of the breadboard. These labels make it easy to follow directions when building a circuit. For example, all of these holes are in column C, and all of these holes are in row 12. Hole C12 is where column C intersects row 12. There are also long strips on either side of your breadboard that are usually labeled with red and black or red and blue lines and also a plus or minus sign. These are called either buses or rails and are used to deliver power to your entire circuit. Typically, the red one marked with a plus sign will connect to the positive battery terminal, and the black or blue one marked with a minus sign will connect to a negative battery terminal. Some breadboards, like this mini one, do not have power buses at all. Some full-size breadboards have power buses that run the entire length of the breadboard, as indicated by the continuous unbroken red and black lines. Other ones have power buses that only run half the length of the breadboard, as indicated by the break in the lines here. This is convenient if you have a circuit that needs to be powered by two different voltage levels. In order to use a breadboard, it really helps to understand how all the holes are connected. Let's take a look at hole A1 as an example. Remember that inside the breadboard are sets of 5 metal clips. This means that hole A1 is electrically connected to hole B1, hole C1, D1, and E1. It is not connected to hole A2 because that hole is in a different row and they do not share the same set of metal clips. It is also not connected to any of the holes on the other side of the gap in the middle of the breadboard. That's holes F1, G1, H1, I1, and J1. We'll explain more about what this gap means in a little bit. This diagram shows all of the connections on the breadboard highlighted with yellow lines. Each set of 5 holes forming half a row, that's those on the left in columns A through E, and those on the right in columns F through J, is electrically connected. The power buses run vertically on the sides of the breadboard and are typically connected over more than 5 holes, although this can vary from breadboard to breadboard. The individual power buses are not connected to each other. Let's take a look at what all this means for a common demonstration circuit with a battery, a resistor, and an LED. When I turn the battery pack on, the LED lights up. Pretty simple. Now let's zoom in and see how I actually have everything connected on the breadboard. The battery pack's red lead is connected to the power bus on the right side of the breadboard. This is connected to a jumper wire that goes to row 5, which then goes to the LED, over to row 5 on the other side, to a resistor, to the ground bus, and then to the battery pack's black lead. This diagram shows how electricity flows through the circuit using yellow arrows. This is called a closed circuit, or a complete path for electricity to flow. Remember that on each separate half of the breadboard, the holes in row 5 are electrically connected to each other. This means, for example, that I can take the leads of the LED and move them to different holes in row 5 and it will still light up. However, if I take the LED and move it to a different row entirely, like row 4 or row 6, it does not light up because there is no path for the electricity to flow. It has to be in row 5 to have that complete path. You can also reconfigure the entire circuit. For example, here I'm going to move the LED and the resistor over to the right side of the breadboard, and then connect the battery pack's negative lead to the ground bus on this side. While this looks different, electrically it is the same circuit, so the LED still lights up. You can see that in this diagram by tracing the yellow arrows, and noticing that there is still a closed path for the electricity to flow through the LED. Now let's take a look at some of the most common mistakes that students make when learning to use a breadboard. Here we have the demonstration circuit from the previous part of the video, with a battery, a resistor, and an LED. At first glance, everything probably looks fine, but when I turn the battery pack on, the LED doesn't light up. You won't know why unless you look closely at the breadboard. When we zoom in, you can see that one of the LED leads is actually in the wrong row. Notice how all of the connections are in row 5, except for this lead of the LED, which is in row 4. Remember that rows 4 and 5 are not electrically connected, so in order for electricity to have a complete path to flow, we have to move that LED lead over to row 5, and then the LED will light up. Every time you build a circuit, you should always double check your wiring to make sure your connections are in the right place. Another common mistake is not firmly pushing leads or wires into the breadboard all the way. Watch what happens if I pull this jumper wire out slightly so the connection is loose. The LED will still light up intermittently, but bumping the wire or shaking the breadboard can easily make the LED go out. To make sure the connection stays secure, you have to make sure the jumper wire is pushed firmly into the breadboard on both ends. The same goes for other components like the LED itself. You can see that if I pull the LED out slightly, it might look like it's actually pushed into the breadboard, but it's actually very loose and won't stay lit. This is because the leads aren't pushed in all the way, so to make sure it stays on, you have to make sure the LED is pushed firmly into the breadboard along with the rest of the components. The next common mistake will depend on the individual components in the project you're doing. Some components have polarity, meaning the direction they are facing matters. LEDs are a great and very common example. Notice how if I grab the LED and flip it around, it doesn't stay lit. If you look closely at an LED, you'll see that the two legs are actually slightly different lengths. The longer leg is the positive side and has to be connected to the battery pack's red lead. The shorter leg is the negative side and needs to be connected to the black lead. The resistor, on the other hand, does not have a polarity associated with it, so I can flip the resistor around and the circuit will still work just fine. When using a breadboard, you'll have to decide what type of jumper wires you want to use, and there are several different types available. First are these long flexible wires that come in many different colors and are usually sold in packs of at least 10. The wires themselves are very flexible, but they have metal pins attached to their ends that make them easy to press into the breadboard. While these wires can be very convenient for simple circuits, they can get very messy with complicated circuits, and as you add more and more to a breadboard, you'll eventually get a tangled nest of wires that can be very hard to keep track of. Another option is to buy a jumper wire kit. This is a small plastic container that comes with many different colors of wire that are pre-cut to certain lengths. The ends of these wires are bent down 90 degrees, which makes them easy to press into the breadboard and keep the wire flat, which can make the circuit much neater than the longer, loopier, flexible wires. The downside of these kits is that they usually only come with 1 or 2 lengths for each color, which can make it difficult to color code your circuit. The final option is to purchase special spools of wire called hookup wire, and use a tool called a wire stripper to cut them to length and then strip off some of the insulation to make your own jumper wires. You can see here I'm just taking a spool of wire, cutting a short segment of it, then using the wire strippers to strip insulation off of each end. When you're done, you just have to bend the ends of the wire down and then you'll be left with a piece similar to what comes in the jumper wire kit that easily fits into the breadboard. The advantage here is that you can buy several spools of wire of different colors and then cut them to any length you want so you can color code your circuit. If you do decide to buy your own hookup wire, you need to make sure that you buy solid core wire and not stranded wire. Solid core wire has wire made of a single solid piece of metal that is very stiff and easy to push into a breadboard. Stranded wire is made up of multiple individual smaller strands, kind of like a rope. This makes the overall wire much more flexible, but the ends are also flexible and therefore much harder to push into a breadboard without just bending them. If you were watching closely earlier in the video, you might have noticed that I actually violated this rule when I connected the battery pack, which comes with stranded wires. If you're in a pinch, you don't have access to solid core wire or a soldering iron, you can take the end of a stranded wire and twist the strands together as tightly as possible, and that will make it somewhat easier to push into the breadboard, but it's still not the easiest way to go. Finally, all this time you might have been wondering what this gap that goes down the middle of the breadboard is for. This gap is designed such that integrated circuits, sometimes just called chips, that come in a dual inline package, meaning they have 2 rows of pins, can fit nicely straddling the middle of the breadboard. When you have a new chip, you might need to bend the pins together slightly so they'll fit into the breadboard, but then you just have to line up all of the pins and press it in firmly just like you would with any other component. This works great because now the pins on each side of the chip are each connected to their own row. What you don't want to do is put the entire chip just on one side of the breadboard so it's not straddling the gap. Remember that the pins in each row on either side of the breadboard are electrically connected to each other, so if you put a chip in like this, you're shorting out the 2 pins in each row. Integrated circuits come in many different sizes, and they all serve a special purpose. However, all of them will fit directly into a breadboard straddling this middle gap. You can find a written version of this tutorial, along with other helpful electronics tutorials like how to use a multimeter and how to strip wire, all at our website, www.sciencebuddies.org. You can also browse our free library of over 1,000 science and engineering project ideas if you need a project to do for school, at home, or just for fun.
Simon and Joe both invest in stocks. Simon uses eToro to invest in stocks without paying commission. Joe has to pay his bank a commission every time.
This video is just the basics about electronic components, what they look like and what they actually do, and how they work in fact. So let's start with one of the most common, the one that I just picked up there, the resistor. So this is a 1000 ohm resistor. I can tell that from the colour bands on it, and we'll look at that later on, how the colour bands are interpreted. However, the function of a resistor, if I use the water analogy, because the water analogy is very good, if you have a pipe with water flowing through it, and part of that pipe is narrowed down to a section, then that will restrict the flow of water through that pipe. Say, for instance, the main water pipe coming into the house, if you put a very thin pipe in line with that, even a fairly short one, then it would really restrict the flow of water coming in, because the water would want to flow through quite quickly, but it would be forced in through this narrow channel, and the resistance posed by that narrow channel would limit the water flow in the same way that a resistor does exactly the same to electricity. It limits the flow of electricity, the flow of current. And in this case, with the water analogy, the pressure of the water equals the voltage. And it's quite interesting that the Chinese sometimes refer to the voltage as pressure, and that's exactly what it is. And the flow of the water equals the current. So the higher the flow, the higher the current. Now, the construction of a resistor is usually, in the case of these ones, this is a carbon film resistor. And you get metal film, carbon film, wire wound, but one of the most common is just carbon film or the metal film. And they have a little ceramic tube which is coated with either the metallized coating or a carbon coating up to a specific thickness. And the thicker the carbon coating on it and the type of the composition they're putting on it, the more conductive it will be. But then they can fine-tune that. They actually cut a spiral round it, and that creates a long, thin path of the carbon, and that increases the value of the resistance. And once they've done that, they put a metal cap in the end with the leads coming off, and they dip it in a sort of, I suppose it's a lacquer really, and typically with the carbon film resistors, which are my favourite, they're one of the easiest to read, it'll be this sort of beigey coloured, I'm not sure, what would you call that colour? I've never really thought about that. Beige, let's call it beige, it's sort of rich beige. And the metal film resistors, which I don't like because they're usually blue and they're really hard to read. The blue colour makes the colour bands, makes it easy to mix like colours like orange and brown because they've got such a dark background. But I'll go into those colours afterwards. So that's the function of a resistor. I'm not going to go into it too much at the moment because at the end of the video I'll cover things like Ohm's law, but I don't want to bore the pants off you, so let's move on to capacitors. Oh, I should continue and say about the resistors. The function of a resistor is to limit the current flow. So say for instance you had an LED, you wanted an LED to light from a battery. If you connected the LED straight across the battery, it would burn the LED out in most instances. But if you put a resistor in series with let's just draw it as a physical